Hiya. This is my first effort at doing a video that is not a live stream, and I do not currently have the editing ability or capabilities to cut together a video. So this is going to be done pretty much like it's a live video, but just may not be my first effort at this so far. So we're going to be talking about the sine rule. Today we're going to talk about the area of a triangle and trying to make sure that that is something that everyone can do. Certainly my year 10s, a couple of them have messaged me and sent me emails saying this is a skill that they're struggling with, so this will hopefully help them. But if there's any topics that you do want me to go through, do always let me know. So without further ado, let's head on in. So what is it we're doing? We are going to be looking at sine rule and area of a triangle. And so we are going to be progressing through and hopefully learning a bit about the background, where they come from, a bit about the area of a triangle, sine rule, and then we're going to review it all at the end. So the background. The background is basically the stuff that we've already done on Pythagoras and on trigonometry. But all of the stuff we did was on right angled triangles only. We did nothing on just what if it's not a right angled triangle. So we are going to take the things that we should already know and build on them. With that in mind, the first thing I'm going to do is give you a warm-up activity. Now, if you feel that you can do this already, or you're looking to get straight on with the meaty stuff, you don't have to do this. Because this is a video rather than a live stream, I'm not going to wait around for people to do it. Feel free to pause the video now. Okay, I'm assuming that anyone who wanted to pause it has done. These are the answers. And we used the height of a tree. We used the area of a garden. So the height of the tree, we used Pythagoras, 15 squared minus 13 squared, and then square rooted it. For the area of the garden, we did 5 times 7, and we remembered to halve our answer. And then for the angle of elevation, we used the cos element of trigonometry because we had the adjacent and we had the hypotenuse. So that allowed us to use cos. With that in mind, what are we going to do? We can't just invent a method. We can't just go, oh, this will probably work. We have to have a method that will A, always work, but it needs to be something called derived. It needs to be something where we produce this as a fact that always exists. You can't just invent something and go, that's not what maths is about. Maths is not invented rules, it is discovered rules. And with that in mind, so here we've got a triangle. And in order to use this triangle, I'm going to label various sides. I'm choosing my letters arbitrarily and I'm just choosing where to put them. So I'm going to put a line down from the top to the bottom to make it into a couple of right angled triangles. Then I'm going to label A, B and C. I chose those. I'm also going to put a D where the drop down line meets the line. This has all been invented and made up. We then add in smaller case letters. These smaller case letters always are the lowercase that go on the sides because it shows the length rather than the angle. So angle DAB, opposite that will be little a because it's directly opposite where the capital A is. Similarly, little b, which is from A to C, this is not from D to C, this is the whole of this base, is going to be opposite where B is, and little c will be here. I'm also going to put an H for the height. Now what I've then done is I've got we know the area of a triangle is half times base times height, which you all knew. But we don't really want H in there because H is not known. The whole point of this activity is that we're trying to learn how we can find the area of a triangle where we don't know the height. It's just we know some of the information. But we also know if we focus on the triangle ADB, we can use trigonometry. Sine A is H over C because opposite over hypotenuse, the opposite of angle, if you look at angle BAD, or just call it angle A, the angle where the capital A is, the opposite to that is H and the hypotenuse is C. Rearranging here by timesing both sides by C, we get that C sine A equals H. But we already have an H in our area, so let's swap them out. So I'm going to highlight the things we've used. Swapping it in, we've got the area is half times the B times C sine A. That means any time you've got any triangle in the world, if you know two of the sides and the angle that is between them, then you can work with it. And there's actually three versions of the formula. You only need one because you choose where to put the letters. We chose where to put A, B and C. So what I would always do is I'd put A as the angle and B and C are the two sides either side. It doesn't matter which way around I've got them. So as you can see, when you have two sides, the angle doesn't want to feel left out, and we want to make sure it's included. It must be included, and by that I mean it's the angle between the two sides that we're talking about. So if I put myself on the screen for a second, I don't want to be in the way, so hopefully I'm not in the way. The angle here, the two sides either side, we would call the included sides, the included angle and the two sides. If I've got these two sides, that's now the included angle. If I've got those two sides, then it's the top one that's the included angle. The angle is the one between the two sides we've got, and we have to have that information to be able to help us. Therefore, we can now go over and do some interesting stuff with this. What we're going to do next is we're going to look at how we can work this stuff out. And here we go. If I have got a triangle, and it can be any triangle, and I'm just told that that is 7 centimeters, and I'm told that that is 9 centimeters, and I'm given the included angle of 41 degrees. Remember, I must have those information. We use our formula of half AB sine C, or half, as we just used, BC sine A. Remember, it doesn't matter as long as they're three different letters. So I'm going to use the one we just worked with. That I'm going to label A, making that one B and C. Remember, this is now different from the diagram we had. It doesn't matter. They're just labeling B and C. So the area must equal half times 7 times 9 times sine 41. So I grab my calculator, and I've got half times 7 times 9 times sine 41, and this will always find you the area of the triangle itself. So because it's area, we need to make sure, and I'm rounding it, it's centimeters squared because it was an area. So it must be centimeters squared. This will work whatever the triangle is you're given, as long as the angle you've got is the included angle and it's not just a random angle. That is a skill that you need to practice. I'm only going to do one example because you can watch it again if you're confused about it. I'm going to head back over to where the next bit of information. Now, if we take for granted that the area is half BC sine A, remember there were three versions, but we're going to take that as this is now a fact. Area is half BC sine A. But remember, we chose how to label this. So we could have said that the area is also half AC sine B. If we focus up the top and use the B angle, we could have moved the H and put it anywhere. This will work in any of the three combinations: BC sine A, AC sine B, or AB sine C. Any of them work. Because they both give us the area, they are the same as each other, so we can equate them. We can say that they're equal to each other. However, you may have noticed both sides here have a half and both sides have a C in them. So I'm going to eliminate those. I've got rid of the half and the C from each side. The final step is I can divide by sine B and sine A to put them on the bottom, or I can divide by A and B to put them on the bottom, giving us, if we want this version, A over sine A equals B over sine B. This is the sine rule. This is what it's saying. We could also have equals C over sine C. It all works in exactly the same way, and at no point have I invented anything. I have just used facts to work out the area rule, and I've used the area rule to work out the sine rule. What this tells us that if this will only work if we have pairs of information. We need to have two numbers that go together, an angle and a side, and another angle and a side. Remember, one of those bits of 4 information will be the question. So it'll be what the thing you're trying to find. And there'll be one of two different ways round it. And we will then have a quick look at both different types in my other software. So that is what I'm going to do now. We are hopefully together here, and I've got two different triangles. Don't really want to draw them in highlighter. Two different triangles. And a second one. And we are going to be using these triangles. One we will do the sine rule where we need a side. In order to do that, I will need to have pairs of information. What I mean by that is, let's say this is good grief, I'm getting there. One of these days. That's 8 centimetres. That's 7 centimetres. And I also know that that is that is going to be 52 degrees, and that is going to be 44 degrees. Now, the reason I've done this, I wanted to demonstrate that the 7 is not useful here. That is a pair of information, and that is a pair of information. Those pairs go together. In order, we then use the sine rule, which says we want a side, so we're going to use the A over sine A version. If we wanted an angle, which we'll see in a minute, we will use the sine A on top version. Now I've got pairs, I can say that the x over sine 44 is equal to 8 over sine 52. This is how this rule works. So therefore, in order to get x on its own, I take whatever's on the bottom and times it this side. So x must equal 8 over sine 52 times sine 44. 8 over sine 52. Don't forget to make sure you're in degrees mode, just in case your calculator's been bashed in your bag. And it's 7.05 centimetres. Notice this was not used because it is not part of a pair, and we need pairs of information. The second one we're going to look at is what if we need an angle. There's two types of things that might happen here. I'm going to deliberately give us a slightly broken question. So that's 85 degrees, and that is 31 degrees. And we have this time 9 centimetres, and we want to know what that is. We got one pair, so we can see that's a pair, that and that form a pair. But we don't have a pair of the 9 and a pair with the angle. However, angles in a triangle always make 180, so we can work out this other one. 86, 116, this must leave 64 degrees here. Now I do have a pair, but the thing I want to find is a side. So I'm going to then find out that side by doing this formula again. A over sine A equals B over sine B. So x over sine 85 equals 9 over sine 64. Notice how I didn't know it, so I had to use angles on a triangle to get a pair. If I want x, I'm going to do 9 over sine 64 is times by sine 85, because I want to get that up onto that side, and that is 9 over sine 64 times sine 85. And the answer gives us is 9.97. It's actually 9.98, so let's make sure I'm accurate. And that's going to be centimetres. Now the only time it's going to be any different is if the triangle I give you is when it is giving us an angle. So the question now is, what is this angle? We do know that this is 11 centimetres, and we do know that this is 49 degrees, and this one is 8 centimetres. So we do have a pair and a pair. But because what we want is an angle, the version we're going to use is sine A, over A. I want to use that the other way around because I want the small case within there. So sine capital A over A equals sine capital B over B. What this means is sine of our thing we're finding is 11. Remember, we can label it A, little b, b, is equal to sine 49 over 8. So we then get sine theta on its own by doing the same thing as before, times what's on the bottom, sine 49 over 8 times 11. But this time is slightly different because we haven't, when we work out times 11, we haven't got the angle yet, we've got the sine of the angle. So this tells us that this number is equal to 1.037. Something must have gone wrong here. I must have made a mistake with the question because it cannot be bigger than 1. So let me have a quick look. And what it's saying is there's no way with the angles as they are that we can have a triangle that works with that being 49 and this being 11 and that being 8. Not exactly certain why, but this one itself doesn't work. Let me just confirm, yeah, I've got everything right, because if I do sine to the minus 1 now, it will break. There's no sine to the minus 1 of 1.037. It will just say math error. So therefore, we will do a different question to make sure it works. I will change that side to 11, to 10, just to make sure that this still works, because I want you to see one that works. And the reason it doesn't work is because that 8 makes the number too small. So we've now got, hopefully, one that works. Sine 49 over 10 times 11 is 0.83. And so because it's 0.83, we then have sine to the minus 1 is 56 degrees. And so you just have to be careful. You've got to use pairs that work together, and you're trying to make sure that when you've got the pairs that work together, that you can then work out, do I need an angle or do I need a side? If I need an angle, that goes on the top. If I need a side, then the side one goes on the top. It should allow you to do any questions. Go back and rewind if you need to. Follow through what I did. Just because the numbers weren't quite right, it still makes sense even when it was at 8. It's just that the numbers, it basically made an impossible triangle. There is no triangle you can make that will work with the angles as we had them. So that's the reason that wasn't working. Okay, so if I just head back over to the studio, so to speak, then just a reminder there, you must have 2 bits of information. You must have 2 pairs, either those 2 or those 2. Sometimes you can find a pair by using the angles. Remember, the angles have to add up to 180, so you can find missing angles. So that's all the stuff we've done today. We've looked at all the different triangles and the fact that it works with all triangles. We've looked at the area, we've looked at the sine rule for finding sides, and at the end we looked at the sine rule for finding angles. there's my challenge for you. In the description, you will find links to a worksheet for the area of a triangle, worksheet for sine rule, and I want you to also look on the two sections on how I derive the formulas and practice that and see if you can derive the formulas from scratch. So that if the question said derive the formula for the sine rule, you can show exactly where it comes from. That's my challenge to you. I would love to receive emails. I'd love to receive feedback from you on what you've managed to do. I'd love to see some of the people doing work. If you're watching this video, please consider sending an email to me. All my information is on that screen. If you've enjoyed and learned something, please like and subscribe. This is me just trying to learn to do some videos to help you in this difficult time where we're all stuck at home. Hopefully that's been of some use.